Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone. Good day to you all. My name is Saif Ali Yasir. Our topic is the effect of GD addition on microstructure and mechanical properties of aluminium 18 silicon alloy for automotive applications. Aluminium alloys are used in automotive industry. This is because to save lightweight, to reduce fuel consumption. And the aluminium alloy properties, it's good corrosion, it has good corrosion, lightweight, low specific weight, high thermal conductivity, and also it used in some applications like piston, brake disc, engine, so on. Here we have the question, why silicon used with aluminium? So to answer this question, silicon, when we increase silicon, the strength characteristic decrease, but the hardness of alloy is increased, and also increase the resistance to abrasion, and also silicon decrease the coefficient of aluminium silicon. Aluminium in general used with copper elements and manganese and silicon and magnesium and manganese and silicon, magnesium and silicon. But the important things for our research, silicon, aluminium or silicon, use in application welding rods and automotive parts. Problem statement of this research in hypoeutectic aluminium 18 silicon alloy, because the grain size, the big size, and the coarse shape of aluminium silicon, this make mechanical properties, strength and wear, hardness, make it lower. So that the important to add additive such as rare earth element. So aluminium 18 silicon need to add appropriate amount of rare earth. So in this research we will add gadolinium, and there is limited research for this element. The objective of research to examine microstructure alteration of aluminium 18 silicon alloy with GD additions. Second, to investigate the mechanical properties of aluminium 18 silicon alloy as a result of GD addition. Hypothesis of the research: it is expected that with addition of GD, gadolinium element, in aluminium 18 silicon will improve both hardness and tensile strength. This because the grain refinement, as we see here, the grain is big and coarse. After that, after we add the GD, it will improve the shape and the size. The size will be smaller, and the shape will look like round. The methodology of this research: first, we prepared aluminium 18 silicon alloy in electrical furnace. We melted the alloy at 750 degrees for 5 minutes, and then we add the GD element for 10 minutes to be homogeneous with the alloy. After that, we pour it in the mold, and then we did the mechanical test and microstructure. as we see in next slide. Here we have elemental mapping test. So why we did this test? To ensure that the rare earth successfully format with the component aluminum and silicon. And here we see the pink element for aluminum, and for silicon green. For the aluminum, we see it obviously it's covered most of the image because the highest percentage, and also we have here for the GD in blue color. By using optical microscopy, we measured the grain size and spec ratio for each percentage. For 0% of GD, 0.3, 0.5, 0.8, and 1% of GD. We get these images by optical microscopy, and we measure for the grain size and spec ratio, and we get this result. For 0% of GD, it was 42 to 63, and as it is obvious, the perfect one and the smallest grain size, it was in 0.8 between 17 to 27, and also for 1% it get back like 0% from 48 to 53, and also for the aspect ratio for 0% between 1.1 to 1.6, and for 0.8, 1.1 to 1.1. For the XRD, X-ray diffraction, we have here was used to describe the development of the phase caused by the alteration of GD in Aluminium 18 silicon alloy. The highest intensity that we have in 0.8, and also we have the ternary and binary phases. The ternary here on 28.4 theta degree. Here we have the EDS analysis. The mass percentage of GD will increase as we add the GD up to 0.8, and then up to 0.1 to 1% of GD, it will decrease the percentage of mass. This because the binary and ternary, the binary aluminum GD and ternary aluminum silicon GD, as we detected in XRD analysis. So we here see it, the gadolinium first mass have in 0.8 because the density of gadolinium is high. The final test result, we have hardness test result and tensile test result. For the hardness, we have the lower on 0% of GD, and then go up until reach to 0.8. It has 71 HV. And also for the tensile test, we have on 0% of GD 47 megapascal. This one, the ultimate tensile strength, and it's go up until reach to 0.8% of GD. It has 69 megapascal, and for yield strength also we have the lower on the 0% of GD and go up until 0.8, and then after we add more GD it will decrease again. For the elongation also we have the better one on the 0.8. So this result we get it because the shape and the size of the silicon. The size was on 0.8 GD, it was the lower size, and also the shape was round. So we get better result on 0.8% of GD. In conclusion, by adding GD element, it helps to refinement for the microstructure. So the size was decreased, and also the shape be round after we add rare earth element, especially GD. So that after we have more increase, more GD percentage, the size will increase and also it will be coarse. For the tensile and hardness result, it improves and also enhance the surface life of aluminum 18 silicon. So this one we get here from 0 to 0.8 enhance in ultimate tensile strength, and also for the hardness and for the yield strength. Thank you so much for your attention. Goodbye.